to be last week. So because of the last week there is no class, then we will discuss today lah. Okay, the 3.3.1 and also 3.3.2. Okay. So the idea of the independent and also dependent sample. I don't think that we need to discuss anymore. Okay, it is similar as what we did in confident interval. Okay, the idea is similar, how it is a independent sample and how it is a dependent sample. Okay, it is similar. Okay, so the independent sample, because we have two different data from two different set of subject, means that we have two different population. Then that's why the parameter that we have is a mu1 minus mu2 here. Okay, so which one is your mu1? Which population is your mu1? Which population is your mu2? Okay, you can decide based on the question itself. Okay, based on the keyword given. And then we have the mu naught here. Mu naught still the hypothesized mean or the population mean or the true mean. Okay, but most of the time when we have two population, usually mu naught equal to 0 most of the time. But still, when you extract the information, you have to find in that question whether population mean is given or not. Okay, if not, we assume it is equal to 0. Okay, so we still have in general, two type of the statistical hypothesis. We have the two-tailed case, and also this two is a one-tailed case. Okay, so the difference will be on the alpha. Okay, so for the two-tailed case, alpha need to divide by 2. When for the one-tailed case, it's just alpha, no need to divide by 2. Okay. For the traditional approach, the type of hypothesis is very important when we make a decision letter. Okay, so the formula itself, how we choose the formula still similar. The idea is similar as what we did for the chapter 2, the confident interval. Okay, basically we have 3 conditions. Okay, we have 3 conditions that we need to determine in order to choose the formula. Okay, the first condition, whether known or unknown, your population variances. Okay, so because of you have 2, then whether known or unknown. And then if unknown, then the second condition is equality of the population variances. Okay, so until we discuss 3.7, these 2 conditions will be given in your question. You can find somewhere. Okay, after we discuss 3.7, so sometime in order to determine whether we have equal or unequal, you have to perform the hypothesis in 3.7, the ratio of 2 population variances. Okay, and based on that hypothesis, you make your decision. Okay, based on the decision, you will know which one that you support, which one that you accept and need to use, whether equal or whether unequal. Okay. After that, the third condition, that's your sample size, whether both less than 30, or whether both greater than equal to 30. Okay, so the formula similar as a confident interval. The difference is here we use the task. So then you have the Z task and also the T task. Okay, so we go to the exercise 3.3.1, number 3. Okay, the one that I asked you to do. Okay. Okay, so we go to the first step before we solve is to extract the information. What is the variable? in this study? The verbal. Anyone? The verbal. Anyone?
The effectiveness of using music during working hours.
Okay, the effectiveness of using music during the working hour. This is what we call the reason why we conduct this study. Okay, the reason why we perform this experiment is to investigate the effectiveness of using music during the working hours of a business. Okay, verbal is the data that been collected, the raw data that been collected. What is that?
Productivity level.
Productivity level. So the easiest way to determine the verbal, it is based on the calculated value. The value that you have in that question, for example, mean, standard deviation, the proportion, they will calculate based on what? Okay, so that what is your variable. Okay, value must be calculated from the data. So data is our variable. The raw data is our variable. Okay, so productivity level. Okay, so variable is very important for the hypothesis testing. Okay, as what we have discussed before, okay, it will influence your hypothesis, the statistical hypothesis. Okay, so we have two different situations here, when the music turn off and also when the music turn on. Okay, so you can write here music off and also music on. Okay, and then what kind of information that we have? So when the music was turned off during the working hours, the mean and standard deviation of the productivity level for 45 employees were found to be 5.2 and also 2.4. Please ignore the background because today I work from home and my neighbor renovate the house. Okay. So 45 employee here. What is that? It is? And. Okay. So 5.2 and 2.4. 5.2.
Mean.
Notation.
X
X-bar.
S bar. Okay. And then we have 2.4 here. It is
S.
S.
S. Okay. So you can write here. Two and 2.4. Okay. On a different day, the music was turned on and the mean and standard deviation of productivity level for 40 employees were 4.8 and 1.2 respectively. Okay, so the 40 here, the 40 here,
And for
N.
music.
and when the music turned on, 4.8,
X bar.
S bar, and 1.2 is your S. Okay. Okay, so do employees perform better at work with the music playing? This is what we need to answer. So this is your hypothesis. Okay, what can we conclude at the 0.05 level of significance if both population variances are the same? Okay, so 0.05 here,
Alpha.
alpha. Both population variances are the same. What does it mean? How to write this statement?
Both variance is equal.
Both variances are equal. So sigma 1 equal to the sigma 2. Okay, so based on that, we have alpha 0.05 and then we have sigma square of equal to the sigma square on. Okay, and then we go to the hypothesis. What we can conclude. So we know that in order to conclude, we have to form the task. Okay, and then we have two population, and the keyword is a two population. Then we know that it is a method from chapter 3 lah. If you have more than two population, then it might be hypothesis for chapter 4 later. Okay, in chapter 4. Okay, so we have to perform the hypothesis testing. The first step is to formulate the hypothesis. Okay, so the keyword is, do employees perform better at work with the music playing? Okay, so we know that we have the quantitative data, the productivity level, the quantitative data. So the parameter that we can use here, it will be either mu or sigma. So why here we have mu? Okay, that one you have to understand. Why here we have mu? Okay, in this study, we do not have special condition like the employee perform better if the variance blah blah blah. Okay, if you have special condition like that, then it is sigma. Usually when we need to use sigma as our parameter, it will be some special condition that relate to the verbality. Okay, but here we don't have that special condition. Okay, so you are given some information here, and then you need to conclude whether do employees perform better at work with the music playing. So we know that we have quantitative variable, then the most common parameter that we will go first is a mu. Okay, so that's why here we consider mu as our parameter. Okay, when you have your own experiment, when you conduct your own experiment and you collect the quantitative data, the first parameter that we will use is a mu. That's a common one. Okay, it's a mu. Okay, unless you have the special condition, unless you want to determine something based on the verbality, then we go to the sigma. Okay, so similar to here lah, if you have special condition that relate to the verbality, then we go to the sigma. If not, we go to the most common one for the quantitative variable, which is mu. Okay, so parameter is a mu. Then we need to decide. So we already know that it is a mu. Okay, so that's right here, mu. And then we need to decide which one should be the first population, music off or music on. So do employees perform better at work with the music playing? Which one should be the first one? On or off?
On.
Why on? Why we decide on should be the first one? Because what?
Work with music.
With the music playing. The key word here, music playing. So on should be the first one. Okay, so we need to decide on sign pula. So perform better at what? What sign should be? Perform better. That reflects to perform better.
Greater than.
Why greater than?
Perform better.
Perform better.
Okay, so one of the keyword is a perform better, but if you still remember when we discussed previously, perform better is not necessarily greater than. Okay, but here it is greater than. Why? Because of what? It is greater than. If we change that something, we might get less than for perform better. Is that?
Productivity level.
Productivity level, the variable itself. Okay, because the variable we have the productivity level. So if the employees perform better, the productivity level should be increased. That's why we have greater than. Okay, if we change the productivity level here, we might get less than. Okay, let's say that defective item, the most simple one, defective product. So it should be, if perform better, the defective product should be less than. So perform better in that case is less than. Okay, but here because of we have productivity level as our variable, as our data that being collected, so perform better should be greater than. Okay. So, do we have a new note here? Ada population mean from this information? Is there any new note here?
No. No.
No.
Now or H1?
Which
H1.
one?
H1. So H now opposite to that. Okay, so claim will be at
Which one?
H1.
okay, so when we have mu naught equal to 0, then you can write your hypothesis in this form. Another form to write the hypothesis, you can write H1 mu on greater than mu off. Also correct lah. Okay. When you have mu naught equal to 0, then you can write in this form. Okay. So, or actually you can also write like mu1 minus mu2 less and equal to the 0, mu1 minus mu2 greater than 0. But if you choose, you want to use 1 and 2 here, okay, 1 and 2 here, you have to notify somewhere lah. 1 to apa and 2 is what. Okay, so to be easy, you just use the subscript based on the question itself. So off and on. So it will be understandable that on and off lah. Okay. Okay, so step 2 formula. The first condition, sigma is known or unknown. In this case, known or unknown?
Unknown.
Unknown. Second condition, we have this equal Third condition,
N more than 30.
n more than 30. So we use formula with the Z test and also S. So it should be at which S bar first? On or off?
On.
On first.
So you have to follow your hypothesis. It cannot be contradict to each other. It cannot the test statistic cannot be contradict to the hypothesis. What you should get? Z test. If you already calculate, anyone?
I got negative 1.04450.
1.04450.
50. Is it correct?
Orang lain? Semua dapat sama?
No,
Same
madam.
answer? Same answer, eh? Okay.
No, madam.
No, you got what?
Negative 0.59531.
Nanti 0.595.
31.
Okay. Anyone?
95, madam. 9531.
9531. Okay. Ready?
Yes.
Okay. Anyone else? You got which answer? The first one or second one?
Second one.
Second one. The rest of you, second one. Okay. So Nik Nur Ashikin, you can check your answer back, eh?
Alright, madam.
Okay. So negative 0.9531. Okay. And then the third step is to find the critical value. So the statistical hypothesis here, the type of hypothesis is what? Type of hypothesis? It is?
Right tail.
Do we need to divide alpha by 2? Okay, so right tail is a one tail, so no need to divide alpha by 2. So you have Z 0.05. It is? One point.
One point 6449.
Okay. Okay, step 4 is to make the decision. So you can plot in your figure here. Okay, so we have negative 0.9531. So somewhere here. Okay. So Z test less than. So decision is? Decision is?
Accept.
Can we write accept Hishna?
No.
No.
We write do not reject Krishna.
Cannot write as a accept Hishna. The correct one is do not reject. Ashna. Okay, do not reject. Ashna. So what happened to the claim? Do we accept the claim? Do not reject Hashna. Do we accept the claim here?
No.
No. Okay. So do not reject Hashna means that we support the Hashna here. Okay, so we reject H1, automatically we reject claim because claim at H1. So you can write here at alpha 0.05. Sekejap Okay. So at alpha 0.05, there is enough evidence to reject. Okay, one of the way or one of the conclusion that you can write. Okay, or you can write here, there is not enough evidence to support. Also correct, or you want to answer this question, do the employees perform better at work with the music playing? So it is not true lah. You can answer at alpha 0.05. It is not true that employees perform better at work when the music playing. Any question? Okay, if you are the manager, should you turn on the music during the working hours?
No.
No. Okay. Based on what you conclude here, you as a manager, you must not turn on the music during the working hours. Okay. So we go to the dependent sample. Okay, so the idea of the dependent sample, okay, we have discussed in chapter 2. Okay, so here we have two different data set which coming from same population, or two different data were collected from same subject, so same population. Okay, but to analyze the dependent sample, those two data we combine together. So how to combine? It is by calculate the data difference. Okay, so after we calculate the data difference, you will have single data. So the rest of the analysis, it is based on that single data. Okay, so that's why the hypothesis will be only mu, single mu, but here you have mu d, so d represent data difference. Okay, So for the formula, you should have three different formula as a single mu. You still need to know whether sigma square D known or sigma square D unknown. And then if unknown, then you need to know n less than 30 or n greater than 30. Similar as a single population mean. Okay, the difference is we have the D. So mu D is for dependent sample, D represent data different. Okay. So how we formulate the hypothesis for the dependent sample? We start from independent sample. So first we regard this one as an independent sample. After that we transform into mu D. Okay, so let's take a look to the number one here. Okay, first one, hypothesis, apa tu, variable. The variable in this question. Variable, anyone? It is what?
Weekly loss of worker hours.
Of worker hours due to accident. So this is the variable. Okay. In 10 industrial plant for before and after the installation of an elaborate safety program. Okay. So data before and after were collected from same 10 industrial plant. Okay. So we have same population, which is this industrial plants. Okay. So by assuming the data are approximately normally distributed, test the hypothesis at 0.05 level of significance either the safety program is effective or not. Okay, so when you have this kind of question, do not jump to the data different first. So first we already know it is a dependent sample. So do not straight to the calculate the data different, because the data different, which one minus which one, it is based on the hypothesis. Okay, based on the hypothesis we decide whether before minus after or after minus before. Okay, so you have the sample data here. So after you calculate the data difference, okay, all the value that you calculate from the data different will produce statistic. So you will have S bar D and also the SD. Okay, so we go to the hypothesis. Okay, safety program is effective or not? That's the keyword. Okay. So we start formulate the hypothesis from the independent. Okay, we formulate as an independent first and then we convert into mu D. Okay. What happened to the weekly losses of the worker hour if the safety program is effective? What happened to this data? How we know the safety program is effective? This is your hypothesis. So how we know if the safety program is effective? Anyone? How do you formulate the hypothesis here?
After is less than before.
What again? Again, apa dia? How to write the hypothesis so that the safety program is effective? What happened to the variable?
The after hour will be less than before.
After hour should be less than before, so that we can say that safety program is effective. Okay, so it is the mu after should be less than mu before, then the safety program is effective. Okay, so here we have to determine based on the verbal. So same as before lah, verbal play important parts in hypothesis. Okay, so this program will effective if, okay, if the workers hour due to the accident reduce. So that's why after should be less than before. So we have mu A less than mu B, and based on this question we cannot find the population mean, so it is equal to 0. Okay, so from here we can write mu A minus mu B less than 0, and then we transform into mu D. Okay, so dependent sample, we cannot write the hypothesis as a independent. Okay, so that's why we need to transform into mu D. So mu A minus mu B, it is mu D. Okay, so from here we have mu D less than 0. H0 or H1? It is
H1.
H1. Okay, when we formulate hypothesis for the dependent sample, we need to notify what is our D, what is our mu D. So where mu D is a mu A minus B, then we can decide for the data different, it is A minus B. It is after minus before. Then you can proceed to the rest of the analysis. Okay, so step 2, do we have sigma in this question? Sigma is known or unknown?
Unknown.
Unknown. Okay, and then we have n less than 30. So we have theta. Okay, so for the dependent sample, sometimes we can have more than one hypothesis. Okay, is it correct if we say here, the safety program is effective if mu B greater than mu A? Correct or not? Data before should be greater than data after, then the safety program is effective. It is correct or not?
Yes.
Yes. Okay, so another hypothesis that you can write, mu B greater than mu A. So mu B minus mu A greater than 0. So this is your mu D. Okay, so another hypothesis that you can write, mu D greater than 0, mu D less than equal to the 0, where this mu D, it is a mu B minus A. Okay, so for the data different, it has to be B minus A, before minus A. Okay, step 2, if you choose, okay, this is our first hypothesis, second hypothesis. So step 2, similar, you will get similar value, the different on the sign. One of them you will get negative theta, and one of them you will get positive theta. But at the end, decision and conclusion must be similar for both hypotheses. Okay, if you get different, then something wrong somewhere. So in this case, you can choose whether you want to use the first hypothesis or whether you want to use the second hypothesis. Okay, either one will be accepted. Okay, do not write both lah. Okay, you will get confused later. Okay, either one. Any questions so far for the dependent sample? The rest is yours, similar. Any question?
No.
Okay, so we proceed to the next one. Okay, we have 3.4, the hypothesis testing for the population proportion. Okay, so population proportion automatically parameter is a pi. Okay, so we still have two type of hypothesis, two tail and one tail here. Okay, so pi note here, it is between 0 to the 1 only. If you have in percentage, then convert first into probability. Okay, because when we write the hypothesis, pi note must be between 0 to the 1 only. Okay, so we use the z-test here. Okay, and then we have single formula for the z-test as for the proportion, and then we still have p equal to x divided by n. Okay, so sometime in your question you already have p, or it is not always x in the question. Okay, so it is not always everything you have to divide by n to get the p. Sometimes it is already p in the question. Okay. Okay. So we go to the 3.5 and then we discuss the exercise. Okay, so 3.5, it is about difference between two population proportion. Okay, so we have pi 1 minus pi 2. So similar as a mu1 minus mu2, we can decide which one minus which one first. Okay, so based on the question. Okay, so we still use the z-test, but here we have two different formula for the z. How to determine it is based on the pi note here. Okay, so first one pi note, first case pi note equal to 0, and second case pi note not equal to 0. Okay, for the pi note equal to 0, then you have to calculate full sample proportion here. Okay, for the pi note not equal to 0, then we need to have pi in our question. Okay. Sekejap Okay, so we go to the exercise 3.5 number 2. Okay. What is the variable here? What is the variable? Anyone? Variable? Variable?
Number of car that need major repairs.
Number of cars that need major repairs. Okay, so number of cars that need major repairs. Okay. So here we have population proportion. It is clear that here we have proportion. So parameter will be the pi. Okay. So we have a sample of 400 here, and then 400 for the model 1 and 500 for the model 2. So 400 and 500, they are, what dia? They are
Sample mean. Sample.
the number of the owners for the model 1 and model 2 who report that their car needed major repair within the first 2 years are 53 and 78. So 53, 78, they are
X.
X. If you have 53% and 78%, they are
P.
P. They are P. So no need to convert, no need to find the X and then divide by N. Okay. If you already have the P, then use as it is. Okay. No need to convert and find the X and then divide again with the N to find the P. No. Okay. If you already have the P, then use as it is. So A is a confidence interval. B, determine whether the population proportion of cars from model 1 that need major repair is less than 0.25 at 10% significant level. So it is only model 1. So we have single population here. Okay, the question B, it is about single population. So it is clear that population proportion. So parameter is a pi. Okay. So less than 0.25. So it just pi less than 0.25. H0 or H1?
H1.
H0, H1. Okay, so H0 opposite to that, pi greater than equal to the 0 to 5. Okay. After that, I think you can proceed by your own. Okay, we have single formula only, which is the Z. Thus, we go to the C. Or any question that you want to ask about the B? If not, we just continue to the C. No? Okay. Okay, so you should watch all the video lah before you come to the class, so that what we do during the virtual class just to recall or summarize, okay? So thus the consumer association hypothesis at 1% significant level. Okay, so the hypothesis is based on this statement, consumer association. Okay, so back to the story, we have consumer association wants to determine whether there is a difference between population proportion of the two leading car manufacturers that need major repair. Okay, so different. We know that we have pi. So pi different minus pi different is not equal. Do we have pi not in our question here? Ada pi not tak?
No.
And then we need to decide which one is the first population, model 1 or model 2? Is it mentioned here? Which one should be the first one?
No.
No.
So we have general question, then you can decide by your own. Okay, whether you want model 1 as the first population or you want model 2 as a first population. It's up to you because it is general, two leading car manufacturers. Okay, so let's say that we use 1 and 2 lah. H0 or H1?
H1.
Okay, we can write in this form because phi naught equal to 0. Okay, step 2. So pi naught equal to 0 means that we have case 1. Okay, so we use that test from case 1. P1 minus P2. We have PP pool sample proportion 1 minus PP 1 and 1 plus 1 over N2. What do you get? Anyone? If you're already done? Anyone?
I
Apa
got
yang mm-hmm.
negative 0.9932.
The rest of you get similar? I guess similar. Okay, so negative 0.9932. So step 3. The type of hypothesis?
Two-tailed.
Okay, so we have alpha 1%, then divide by 2. So we have what is the value? Okay, when you have to tell both critical value must be mentioned. Okay, the lower one and also the upper critical value. So you have
2.5758.
2.5758 and negative 2.5758. Okay. Step 4, decision. So if you sketch your figure here, then you can plot. Where is your z-test here? In between or in any side?
In between.
Z-test somewhere here. Okay, when you have z-test in between, it is compulsory. When you write your comparison, it is compulsory to write both sides. Okay, for the case, I repeat, for the case of test statistic located in between two critical value, when you write the comparison, you have to state both. You cannot just state one side. Okay, so it has to be negative less than z test and then z test less than upper critical value. Okay, you cannot just state, for example, z test greater than negative, or you state z test less than 0.05. It is wrong. Okay, so ingat balik test buat apa? Nombor 6. Okay, so that's why I ask you to sketch this figure. If you did a mistake here, I will check on your figure. If you plot correctly, then you will get full mark, no doubt. Okay, full mark. Okay, for this section. Okay, if there is no figure and then you write either 2 here, then you might lose some marks. Okay, because this is not correct. Okay, when test statistic in between, it is compulsory to state both critical value. Okay, so what is your decision here?
Do not reject hash now.
Step 5, What happened to the claim? Do you support the claim?
No.
No. Okay, to reject the claim that there's a different, here you can just copy this one, there's a difference between the population proportion of the two leading car manufacturers that need major repairs. Any questions? Okay, so the comparison here, how to say, it is a crucial one. Okay, the comparison must be correct. If you lose your mark here, you did a mistake on the comparison. Okay, let's say here you just mentioned one critical value, so there is no mark here, so it is wrong actually. Okay, so when here is wrong, automatically here wrong, automatically here also wrong. Okay, so one mistake here, but you will lose 3 marks. So be careful with the comparison. So that's why, to be safe, it is encouraged for you to sketch this figure, and then if you sketch this figure, please make sure that you plot your z-test. You plot your test statistic. Okay, after you plot, make sure to label. Okay, so that reader know it is your test statistic. Okay, any question? Okay. Okay, so if there is no question, we proceed to the next one. Betul ke tak soalan ni? Test nampak different je sebaliknya. Okay. So population variance. Okay. So single population variance. Okay, so the single population variance or standard deviation, we use the chi-square test. Okay, so for the hypothesis, okay, it is depends on the question. Okay, if you are given the condition of the standard deviation, you can write your hypothesis as a sigma. Okay, if you are given the condition of variance, then you can write your hypothesis as a sigma square. Okay, or sometimes you are given standard deviation, you can convert into variance, which is sigma square. Okay, as long as it is verbability, sigma. Okay, sigma or sigma square. Okay, so we have single formula only for the this hypothesis, okay, which is a chi-square equal to n minus 1 s square divided by sigma square node. Okay, so for this case here, sigma square node cannot be 0 lah. It must be some value. If not, it will be undefined letter. Okay, you need to find the sigma square value in your question. You still can hear my voice kan? Ataupun is it too noisy?
Boleh.
Yes, madam.
Okay. Okay, the thing is for the chi-square here, it is different from the z and t. Okay, chi-square, it is a positive distribution. Okay, in which case it starts from 0. Okay, that's why for the lower critical value, okay, and upper critical value here, we have two different value and both positive. Okay, it is not similar as a T and Z. T and Z, they are symmetric distribution. That's why we have positive sign and also negative sign. Okay, so for the chi-square, they are positive distributions, so both are positive. So if you have the left tail, okay, we still have positive value for the critical value. Okay. So you can refer to this now. When you have to tail, then your lower critical value here, it is 1 minus alpha over 2 and also lu. Okay, for the left tail, it will be only alpha. Okay, so we go to this question. Okay, let's do number 3 here. Okay, in a wood cutting process to produce the ruler, the variance of the ruler height is said to be equal to at all times. What is the variable here?
Ruler height.
Ruler's height. This is your variable. If the variance of the ruler height is not equal to the 2, the process will stop immediately. The height for a sample of 10. So this is a sample data. Everything that you calculate will produce statistic. Can we stop the process at 0.1 significant level? Okay, this is what we need to answer. This is what we need to conclude. So this is your hypothesis. Okay, so after you, okay, you have the sample data here, so you can calculate your S bar if you need, and also the S lah. Okay, so we go to the hypothesis. Step 1. Okay, stop the process, go back to the story here. If the variance of the ruler height is not equal to the 2, so it is clear that the condition that we have in order to stop the process is variance. So automatically parameter is sigma square. Okay, so sigma square is not equal to 2. So sigma square not equal to 2. H0 or H1? H0 or H1?
H1.
Can we write this one? Is it correct if you write this hypothesis? Betul tak? This one? Correct or not? Guys, are you still here?
Again, madam.
Again? Apa yang again?
Soalan madam.
Ya Allah.
Line putus-putus.
Ya ke? Tak dengar sangat suara saya?
Tak dengar sangat. Tak tahulah kalau
I
saya tu yang tak dengar.
have this problem since the first class today. Okay, I think because of the internet connection lah. Okay, is it correct if we have this kind of hypothesis?
No, I think.
No. The rest of you?
No.
No.
No. Lagi? Jawapan lain? Start jawapan lain lah kan, saya yes and no je lah. So no the rest of you pun no ke?
No. Don't know, madam.
This one also correct to write. Okay, so the condition is about variance, but also if we write as a standard deviation also correct. Okay, but when we write as a standard deviation, the right hand side here, it is a sigma squared dot. But when we write the sigma, then we have to transform into sigma square lah. Okay, once given standard deviation, just use a standard deviation. No need to go through some trouble to convert the value. Okay, you might be a mistake here later. Okay, especially for the right hand side here lah. Maybe you forget to transform or the value. Okay, so just stick to the variance. Okay, so step 2. Okay, we have the test statistic. Okay, and step 3, we have not equal, so 2 tail test. Okay, make use to to sketch this figure. Even me pun, I always sketch this figure in order to determine the decision. Okay, so we have 2 tail, then alpha divide by 2, so 0.1 divide by 2, we have 0.05. So upper critical value here, we have a value 0.95 and 9. Okay, so make your decision after that conclusion. Any question?
No, madam.
Okay, so I think this one is quite easy. I mean, because of the formula. Okay, as long as you understand why it is a sigma, then it should be okay lah. Okay, we go to the next one, the last one for this week. We have 3.7 hypothesis testing for the ratio of 2 population variances. Okay, so here, okay, the hypothesis here. Okay, so when we have two population variance, okay, you can write your hypothesis in this form lah. Or you can write in the form of ratio. Okay, when we write in the form of ratio, automatically the right hand side equal to 1. It cannot be 0. If 0, then everything will be 0 here. Okay, so H1 not equal to 1. So means that based on this, sigma naught square always 1 for the case of ratio of 2 population variance. Okay, it always 1. You cannot find the value in your question. Okay, but we don't assume to the 0 because of ratio, we need it to be 1. So sigma square naught always equal to 1. Okay. Okay. So for the ratio of 2 population variance here, we use the F task. Okay. So F task we have discussed in chapter 2. We have limitation in our statistical table. Okay. For the case of two tail, so F task similar as a chi-square, they are positive distribution. Then lower critical value will be different to the upper critical value, the value itself. Okay, So for the upper critical value here, you have F alpha over 2, nu 1, nu 2. It is different from the confidence interval. Confidence interval, we need nu 2 and nu 1. But for the hypothesis testing, it must be nu 1 first and then nu 2. Okay. There is a theory behind that lah. That's why confidence interval nu 2 first and then hypothesis testing is a nu 1. Okay, so lower critical value 1 minus alpha over 2, nu 1, nu 2. Okay, as we know it is not in our statistical table, then we have to use the formula. So F alpha over 2, nu 2, nu 1. Okay. So because of we need nu 1, nu 2, then it should be nu 2, nu 1. Any questions so far?
No, madam.
Okay. So we go to the exercise here. Okay, the number 3 here, it is important for me to explain this one. Okay, so A and B, they are related to each other. Okay, so first, what is the variable in this study?
Time taken to assemble one unit from the machine.
Time taken to assemble one unit, okay, of each type of machine. So you have sample data here, everything that you calculate will produce statistic, okay, and there is no more value that we can extract from this statement here. So all the value coming from this sample data. So at 10% significant level, test the difference in variability between the two types of machine. Okay, test the difference in variability between the two types of machine. So variability here is, okay, so we have keyword variability here, means that parameter you can write as a sigma square or sigma. So it is clear that we have variability. So parameter that related to the variability, you will have either sigma square or sigma. Is it clear?
Yes, madam.
Okay. And then difference in variability between the two type of machines. So you have sigma A square not equal to the sigma 2 sigma B square, or you can write as a standard deviation, also accepted lah. Okay, so H0 or H1?
H1.
Okay, so H0 sigma
Equal.
equal. Okay, so the rest you can do by your own. Okay, calculate the F test and then make your decision after that conclusion. Okay, the B. Okay, here I want to explain why A and B related to each other. You cannot answer B without answer the A. Which machine should be installed by the company to assemble its product? Test the hypothesis at 10% significant level and use the assumption of the condition of the variance equal or unequal based on your answer in A. Okay, so back to the here. The company will install machine B if the mean time taken to assemble a unit of the product is less than the mean time taken by machine A. What does it mean? What parameter that we need to use here?
Mu.
Mu. Mean is a mu. So what is the hypothesis here?
Mu B less than mu A.
Mu B less than mu A. Okay, for the B question. Okay. This is a first step. The next step is to choose the formula. Okay, so here we have independent sample. The first condition to choose the formula,
Sigma square is unknown.
So sigma square A and sigma square B in this case unknown. The second condition,
Sigma A equals to sigma B.
second condition is what we call equality of the population variance. So based on this question, how we know the equality of the population variance? Is it mentioned somewhere in this question?
No.
How we know that condition? The rest of you, you can participate, you can answer.
Based on A question.
Based on the A question. Because in the A question, we test the equality of the population variance. Okay. So the second condition here, whether sigma A square equal to the sigma B square or sigma A square not equal to the sigma B square, it is depends on your answer in A. Okay, in A, you test this hypothesis. So, in your decision, after you decide, okay, based on decision and conclusion, then you will know lah, whether okay, in A, I will write here, if decision is do not reject H0. Which one that we use? Equal or unequal?
Equal.
Sigma B. So we use this condition. If reject H0, then we use unequal or equal?
Unequal.
Unequal, opposite to that lah. Unequal, so sigma square A not equal to the sigma square B. Then it is, the third condition is an N. Okay, so that's how the question A and B related to each other. Okay, we cannot proceed to the B without complete, okay, the answer for A, because we need answer for A for this condition. Okay. Okay, one thing, we can use the answer from A if, okay, if the alpha here similar to here, then we can use answer from A. Let's say that we change this alpha to the 5%. So you cannot use the answer from A. You have to test another one based on alpha 5%. Okay, so in order to use the answer from A, alpha must be similar to each other. Okay, so that's how related. That's why I said after we discuss 3.7, the condition of equality, population variance, sometimes you have to test. Okay, in this question, it is a guided question, means that we ask you to test the different instability first and then go to the independent sample. Okay, if you go through the tutorial question, it will be a question that it is not guided one. You have to know by your own. Okay, in that question, you have two different hypothesis testing. Okay, one for durability and another one for the independent sample. Okay, any questions so far?
No.
No, eh? That's good. I have to think how to make our class more interesting. Okay, because 4 to 6, even though we have the physical class pun, it will be because of 4 to 6. Okay, apatah lagi virtual class lah. Okay, so please be more participate in this class so that class tak adalah boring sangat Okay, if not, maybe we have to think another solution lah. Maybe there is no class at all. You want to study by your own, everything?
No.
Oh yes. Okay. If you want to study everything by your own, then I think that we can cancel all the class. Okay. If not, yeah, please participate more lah in this class so that we're not so boring. Okay. Because of 4 to 6, yeah, I know it's time for you to play football and something. Okay. Okay, so thank you for today. See you next week, inshallah. Thank you, class.
Thank you, madam.
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 Okay.